Ladies and gentlemen, my name is Merel Franke, Local Key Account Manager Food for Hach, and I want to welcome you all to the first in our series of webinars from Hach. The presentation will last approximately 25 minutes, and as always with our webinars, we will keep questions until the end of the presentation when we will answer them, and if need be, take them offline to discuss further. The way to ask a question is to type it into the panel on the left of your screen. If you prefer, you can ask in Dutch, but we will answer in English. This presentation is entitled Salt and Total Acidity Titration in Food and Beverages. It is presented by Philippe Pons, one of our application development managers and a specialist regarding electrochemistry and titration. Philippe has worked many years for Radiometer and has been at Hach for the last 17 years. Therefore, has a wealth of experience to bring to this subject. So, let's start, Philippe, and all enjoy.
Thanks, Merel, for this introduction. So, hello, ladies and gentlemen. So, during this presentation, we will focus on two major parameters commonly measured in food and beverage, which are total acidity and salt. So, total acidity and salt are very common parameters in food and beverages. These parameters are used to check the quality of final products or raw materials, because acidity and salt have an impact on the taste. Acidity is an indicator of product quality. Correct acidity and salt guarantee a good preservation, and more actually salt is increasingly monitored due to European health regulations. We speak about two parameters, but which are not measured by the same user. We can measure total acidity and salt in different departments of the same company. We can measure these parameters in R&D, if you need to develop or to create a new formula. We can also measure these parameters during the process line, to check the quality of a product during packaging. And we have also to check these parameters in the quality control labs, either to control the quality of raw material or to control as well the quality of final products. But the question and the issue is that not all users are chemistry specialists, and it's completely normal. So the idea is, how could we guarantee accurate and reliable results for all users? These two parameters, total acidity and salt, can be measured by the same measurement technique, which is called titration. What are the benefits of titration? Titration is a normalized and very often normalized or recommended method by international organizations. For instance, for salt, we follow two norms, or for total acidity in fruit juice or in wine, we follow the recommendation of some different organizations like AOAC for fruit juice or OIV for the wines. And titration as well is easy to perform. It's a non-expensive technical and can be performed on any benchtop because it doesn't take a lot of place. Regarding titration, you can have two different choices. You can choose to use manual titration or automatic titration. If we speak about manual titration, the detection is made by color indicator. So you can see here an example of manual titration system. The titrant is in a graduated burette, and the user will open the tap and will control the flow of the titrant into the sample, and the sample will change of color, and the customer, the user, will stop the titration when the sample will have the correct color. And at this moment, the user will note the titrant volume, will calculate manually the concentration, and will store the data. So all this procedure will be completely manual. But if we take the example of salt measurement, we can see that, for instance, color change is very difficult to estimate visually. If you see here a sample, which is this one is a very clear sample, it's not always the case for all kinds of samples, but this one is clear. As soon as we put the titrant into the sample, the color change, and we will have precipitation. So at the end, when the user will stop, are we sure that we have really reached the real color and the good color to stop the titration? Are we sure that we have stopped the titration at the correct color? Because each user will have a different interpretation of the end color change. So it means that each user, will obtain finally a different result. Regarding automatic titration, the chemistry can be more or less the same, but the procedure will be completely automated. So it means that the detection is no more done by color indicator, but will be done by a probe, which will follow the titration. You can see that the automatic burette contains the titrant. So it means that you have an accurate syringe which will manage the titrant. The operator has only to start the titration by pressing a button. The titrator will add very precisely, with a very strong accuracy, the titrant into the sample, and the titrator will automatically stop based on probe measurement. And at the end, the titrator will automatically calculate the sample concentration and will store the result. So if we take the same example than before regarding salt, we can see that the instrument will follow precisely the millivolt measurements, and there is no doubt about the end point. So it means that the measurement will be always exact, and there is no doubt in result quality regardless of user expertise. It's one of the main differences between manual and automatic titration. But automatic titration has also a lot of other benefits. First, safety. With an automatic titrator, the user is no more in contact with reagents, or as well, we don't use color indicator. If we take the example of total acidity, for total acidity, we use a color indicator which is called phenolphthalein. And now, phenolphthalein is classified as cancerogenous product by Europe and is CMR classified. So now, the Europe recommends to change of technical because we want to avoid to use this color indicator. And also, with an automatic titrator, you can have a real confidence in the results because the accuracy, the repeatability is better than with manual titration, and it can be used everywhere and by everyone, even by non-specialist user. The result quality will always be optimized. It's economic because we use less titrate. Depending on the method, you can use twice or 3 times less titrant for each measurement. You need less titrant to clean also the system, so less time consuming, no risk of spillage of breakage, of glass burette, and the return on investment within a few years. And to fit with your quality control requirements, the automatic titration allows a complete traceability. If you have serial of samples, you can as well very easily automate your measurement by using automatic titration and samplers. With 81000, with this new titrator range, the concept is easy to understand. Automatic titration without any complications. It means that with our solution, we offer a ready-to-use system without programming knowledge. Ready-to-use and optimized method, no need to programming. The system is very easy to use. The idea is to put the beaker on the instrument with the sample, to press a button, and to have a result. It's also a very qualitative offer because we use high-quality technical features, and you have also the expertise and the support of a titration specialist, Hach company. And we have also made a very big effort on the price, and we offer this system at a very competitive price with or without also automation. When you buy a titrator with application kit to perform a specific method, you will receive also an USB stick. This USB stick contains the pre-programmed and optimized method, total acidity, salt, and so on, and also what we call an application note. The application note is a document which explains completely how the method is working. If you want to adapt some things, all the information are clearly explained in the application note. And you have, after only to download to the titrator the method what you need in few seconds, and the method and the instrument will be ready to work. If now we focus more on total acidity. For total acidity, we offer 3 main methods. The first one is a method which is dedicated for pH and total acidity in milk. Total acidity is a very common parameter to check the quality of the milk, and we have optimized a method specifically for this measurement, which express the result in international units like Dornick degree, milliliter of 0.1 sodium hydroxide per liter, or Socklet-Henkel degree. Another method, which is called pH and acidity in fruit juice and wine, can be used for all other liquid samples. For instance, fruit juice, wine, beers, sodas, and so on. So this method will follow international recommendations from AOAC and OIV, for instance, and the results will be expressed in gram per liter of different acids like tartratic, citric, malic, acetic, and so on. You can follow the acid that you want. The third method is a method which is more dedicated for samples in weight. This method is called pH and total acidity in tomato sauce. The sample is in weight, and the results can be expressed in millimole of hydroxide H plus per 100 gram and in gram per 100 gram of an acid that you can choose in a big list of different acids. What is the principle of the total acidity method? Total acidity corresponds to the sum of titrable acids in the product. So it's what we call an acid-base titration. It means that we follow this titration with a pH probe. For this titration, we use a specific probe, which is the model PHC 725, because this model is particularly optimized for food sample because it reduces the risk of coating by particles, sugar, or grease. During this titration, we use NaOH as titrant, so it means that this titration is called increasing titration because when we add NaOH in the sample, the pH increases, like you can see on the picture. When we stop, we will stop this titration with one endpoint. This endpoint, the value of this endpoint is given by the bibliography and can differ depending on the method. For instance, for the method for total acidity in milk, we will stop at pH 8.4. For fruit juice, wine, it's 7 or 8.2, depend of the method. And for tomato in sauce, total acidity in tomato sauce, we will stop at pH 8.1. But if necessary, if you have specific method or internal method, we can change very easily this endpoint value. Regarding the measuring range, so measuring range is dependent on sample volume and titrant concentration. The default sample volume is 30 milliliters for milk, fruit juice, and wine method, and 2.5 grams for tomato sauce method. And you can see here an example of range, result range for different units. Our default methods cover a large type of sample commonly used in food and beverage. But of course, you can also adapt this range for different and specific samples. Regarding the result units, at the beginning, the first result will be initial pH. So it means that this pH is the pH value of the sample before starting titration. And at the end of the titration, the titrator will calculate all results in different units. You can choose the different units that you want. You can display until 5 different units at the same time if you want. And you can see here the different type of units, and you can express the results in different kinds of acids. Very easily, it's already optimized and defined in the method. You can choose the unit that you want. Second method, salt. Regarding salt, we have two different methods which are based on ISO standard. So it means that we have one method which is dedicated to sample in volume for liquid food, and we have another method which is for sample in weight for solid food. In liquid food, we will express the result in gram per liter of NaCl, and for solid food, we will express the result in percentage of NaCl. Regarding the principle of a titration, so this kind of titration allows to determine the salt in the sample and uses a titration with silver nitrate as titrant after sample dissolution in water and in an acidified environment. So this kind of titration is called precipitation titration because you have a lot of particles which are created during the titration. And this titration use a probe which is a silver probe, so it means that the sensitive part is made with silver bar, and this sensor doesn't need to be calibrated. For this calibration, we use as titrant silver nitrate to perform this titration. This method, this titration, must be performed in an acidified environment. So it means that when a user wants to measure salt by titration, he has to add manually in the sample some acid, nitric acid, in the sample before starting titration. With AT1000, it's automatically done by the instrument itself because the instrument has two embedded pumps to add automatically the acid before titration, and automatically the system will continue by the titration after the automatic addition of acid. So it's very safe for the customer because the user doesn't need to manually add concentrated acid into the sample before titration. It's automatically done. Regarding the method, it's also an increasing titration, so it means that when you add silver nitrate in your sample, the millivolt increase, so you will have this kind of curve, and the system will automatically find the inflection point, which corresponds to the volume that you need to calculate the correct result. As soon as the instrument will find this equivalent volume, it will be able to calculate the result and to give you the result in the correct unit that you have selected. Regarding measuring ranges, of course, measuring range is always dependent on sample concentration, sample volume and titrant concentration. But by default, with our default methods, we use a sample volume of 50 milliliters for liquid method, and we will use 5 grams for solid method. And if you have here a look on the result ranges, the result will be expressed in gram per liter of NaCl or percentage of NaCl, and we will cover the majority of the needs for the majority of the samples, but in this case also, if you need to extend the range and if you need to have another range, it can be really very easily changed in the setting if you want to have other units or other ranges. One thing which is interesting also to know is we use one titrant for total acidity and we use another titrant for salt. So it means that if you have an instrument with two burettes, it means that with the same instrument is able to manage two different titrants. You can perform total acidity and salt on the same instrument. It means that, for instance, on the left part, you can see that we can install for total acidity NaOH titrant in the first syringe, and we will use the pH probe for total acidity. And we can install for salt silver nitrate in the second syringe. We use the silver probe, and the nitric acid will be automatically added by the pump. So it means that with the same instrument, you can perform 3 different measurements: pH, total acidity, and salt. And you will have an instrument which will be always ready to work, because we are speaking clearly about routine measurements. So it means that if you want to use it for salt or for total acidity, you have nothing to change physically in the instrument. You have only to call the correct method, and you will be able to launch immediately the correct titration. Other feature: if you have a large serial of samples, you can automate. So it means that you can connect to the titrator a sampler, and this sampler, we have different capacities of sampler, but you can connect this sampler, and the system will automatically perform the correct titration in each beaker. You will be able to create a list of samples, and the system will automatically measure each beaker with no need of the user. So it means that the user will have only to launch the sequence and will be able to do something else during the measurement. So a sampler is very useful, because with a sampler you can save time. So it means that you can save money. And with our sampler as well, we have a very, very competitive price. So it means that with our configuration, titrator plus sampler, you can have a very short return on investment due to this very aggressive and competitive price. So, in summary, total acidity and salt are measures parameters in food and beverage. Titration is a simple, non-expensive, and normalized method for measuring these parameters. Automatic titration has a lot of benefits compared to manual titration and guarantees correct results everywhere and by everyone. You don't need to be an expert. AT1000 offers pre-programmed method and optimized method ready to use, and total acidity and salt can be performed on the same instrument and easily automated if needed. So, thanks for your attention, and if you have questions, don't hesitate to write them, and we will be able to answer you. Thanks a lot.
Okay, Philippe, thank you very much. For me, it was clear. I hope for the participants as well. Let's go to the questions. Let's see what we can find. Philippe, you are telling us about a very competitive price, but could we have an idea of this price you were mentioning in? Or shall I answer that for you?
You can answer if you want.
Yes.
to give an idea to.
Yes, when you go to the Dutch market, you see that one titration unit for total acidity, a complete package. So this means the instrument, but also the electrodes and also the USB and everything on it, it's about 2,900 euro for total acidity. When you want to do a salt titration and you only want titration unit for salt, then it's about 3,000 euro. Do we look to a combination? That's also possible on one unit. Then the whole package will be about 4,250 euro. And in the end, you let us show Philippe the auto sampler. For the people who do a lot of titrations a day or a week, it would be a nice thing to order as well. An auto sampler, including the software, is about 5,600 euro. So it means when you want a whole package with auto sampler, software, total acidity and salt, it's less than 10,000 euros. These prices I mentioned are without reagents and installation. Well, the only thing I can say, if you want a quotation from us, please make a question and then we will take care of it. I hope everyone did find the questions. I have another one for you, Philippe. Another question is coming in, and it is, what is the maintenance of an automatic titrator?
Okay, so the maintenance for an automatic titrator is very low because, in fact, it's not like manual titration. For instance, we have not to rinse the system and so on. So, for instance, if I take the example of the total acidity, you will have only to calibrate the pH probe like a pH meter. All is automated. You have guided, so it's very easy to do. You have not to rinse, to purge, and so on the system. You have only to purge the system each day that you want to use it, but it's automatic. You have to press a button, and you have and you have no more maintenance for the system. Once for each 2 years, perhaps you will have to change the probe, okay, and perhaps the tubes 2 years also. Really, it's a minimum. An automatic titration doesn't need a lot of maintenance.
Okay, I think that is clear. A final question, and I think it is the last one. I can't see other ones, but please, if you have one, you can drop it in the Q&A button. The question is, Philippe, do you stir the sample during the titration, and how?
Yes, of course. It's always necessary to stir the sample during titration because when you add titrant in your sample, you need to be sure that the titrant will be correctly homogenized in the sample to ensure a very good chemical reaction. So on the instrument itself, perhaps you can see it always on the picture. Under the blue beaker, there is an internal magnetic stirrer. So it means that you have only to add a magnet bar in the beaker, and the system will automatically start the stirring and will stop also automatically the stirring as necessary. If you need for specific sample another type of stirrer, you can add an external stirrer with a propeller, which will be able also to stir the sample and which will be also managed automatically by the titrator.
Okay, thank you, Philippe. I was looking to a new question. People are asking if it's possible to share the slides. Well, what we all do with these webinars, we record them. So we record all our webinars. So you will be able to watch this webinar on the Hach YouTube channel. And after this webinar, a link to this channel will be sent to you afterwards. So everyone is able to see and oversee this webinar again. And you can share it, of course, with your colleagues. I'll have another question coming in. What about measuring the water content? That is also a major parameter in the food industry.
Yes, water content. Water content is another important parameter in food, and not in beverage, but in food. And this parameter can be measured by another dedicated titrator, which is called Carl Fisher titrator, because we use a Carl Fisher technique. So this titrator is dedicated to Carl Fisher. So you will be able to perform only Carl Fisher with this method. The main difference with a classical potentiometric titrator is that we use a glass cell which is completely waterproof, because we don't want that humidity from air comes into the cell, and we will use two embedded pumps which are already embedded in the titrator to manage the solvent, because when you perform Carl Fisher, you put a solvent in the cell, you put your sample, the system will titrate and will measure the water content, but after a certain time, you have to remove the solvent from the cell and to put fresh solvent in the cell. All these solvent and the titrant for Carl Fisher are not very safe. So we have automatic pumps to automatically remove and refill the cell between measuring, after a certain number of measuring. But it's a completely dedicated instrument for Carl Fisher. It's another method and it's another instrument which looks like this one, but which is optimized for Carl Fisher method.
Okay. I think that brings us to the end of this webinar. Thank you, Philippe, and thank for everyone for these questions. We will inform you by emailing of our next webinar in our series, and that is planned for 2018. As I said earlier, we record all our webinars, so you will be able to watch them on the Hach YouTube channel. And like I said before, a link to this channel will be sent to you afterwards. That brings us to the end. Thank you all very much for attending, and we look forward to speaking to you again soon. And please don't hesitate to contact us for questions or remarks. Have a good day and a good evening. Goodbye, everyone.
Thank you. Bye-bye. Okay, so